Throughout history, sugar has played an integral role in human diets. Introduced to the Western world by the Arabs in the 8th and 9th centuries, sugar was initially a luxurious spice due to the complexities associated with its production. However, with the advent of the Industrial Revolution, the sugar industry underwent a transformative change and is now valued at a staggering $67 billion. In the United States, the production of sugar primarily relies on two sources, beets and sugar cane. Approximately 55 to 60% of sugar production comes from beets, while the remainder is derived from sugar cane. Interestingly, each of these sources necessitates distinct climatic conditions. Sugar cane thrives in tropical and subtropical regions, while sugar beets flourish in temperate climates. Today, Brazil is the world's largest producer of sugarcane, accounting for approximately 40% of global production. The country's dominance in sugar production is attributed to its vast land area suitable for cultivation, favorable climate conditions, and significant investments in technology and research aimed at improving yields and processing efficiency. Additionally, Brazil is a leading producer of ethanol derived from sugarcane, which is used as a biofuel in transportation. The cultivation process commences with the careful selection of suitable land. The land must possess favorable drainage, access to water, and fertile soil. Sugarcane is primarily propagated through stem cuttings known as scent, while sugar beets are grown from seeds. It takes approximately 12 to 16 months for the sugarcane plant to reach maturity, signaling the onset of the harvesting season. In the United States, specialized machinery is employed for sugarcane harvesting. The harvested sugarcane is fed into a conveyor, which transports it to a bin alongside. Subsequently, the sugarcane is loaded onto trucks and transported to the mill. Upon arrival at the mill, the trucks unload their contents onto a receiving table wherein the soil and rock are separated from the cane. To prepare the cane for further processing, it undergoes a thorough cleaning process involving strong jets of water and combing drums to eliminate any undesirable debris. Once cleaned, the cane's tough structure is broken down within a crusher, utilizing rotating hammers to reduce it into smaller pieces. The crushed cane is then fed into a milling tandem comprising several large cylinders that compress the fiber, extracting as much juice as possible. The extracted juice is directed away from the leftover pulp known as bagasse, which can be utilized as a fuel source. Throughout the milling process, quality control efforts are meticulously upheld at each stage. Following the successful extraction of the juice, it is subjected to rigorous testing in the sugar mill laboratory. These tests purify the juice and measure its sugar concentration, ensuring consistent quality, optimizing processing, determining sugar yield, establishing fair prices, complying with regulations, and facilitating scientific research and development. The purified juice undergoes sulfitation, wherein it cascades down a 10-meter tower while sulfur dioxide vapors rise through it. This process preserves the juice by inhibiting the growth of microorganisms and balances its slightly acidic nature. In a separate vat, workers prepare a lime solution by adding powdered lime to water. This solution is then mixed with the juice using an agitator for approximately 6 hours in a process called alkalization. Alkalization serves to regulate the juice's pH level and clarify it, leading to a color transformation from brown to yellow. Subsequently, the juice is transferred to clarification tanks, wherein any remaining impurities settle over a span of 2 hours. Rather than discarding the residue, also known as mud, workers filter it to extract any remaining sugar. The extracted sugar is then removed while the leftover mud serves as a fertilizer for the cane fields. The purified juice, now free from impurities, undergoes boiling in a series of evaporators to facilitate the crystallization of sugar. This intricate process marks a crucial stage in the production of this beloved commodity, paving the way for its eventual transformation into the crystalline sweetener that graces our tables. Each subsequent evaporator in the process operates at a higher pressure, resulting in a lower boiling temperature for the sugar. This evaporation process effectively removes approximately 2/3 of the water content from the juice, significantly increasing the concentration of sugar from 15 to an astonishing 60%. The concentrated juice is then collected in 15-ton tanks for further clarification, where any remaining impurities rise to the surface and are subsequently skimmed off with the assistance of a rotating paddle. The final tank produces a syrup-like substance with 65% solids and 35% water. The next step in the sugar manufacturing process is crystallization, which occurs in a single-stage vacuum pan. The syrup is evaporated until it becomes saturated with sugar. At this point, workers introduce sucrose crystals suspended in alcohol into the syrup, acting as seed crystals to initiate the rapid and uniform growth of new sugar crystals. This crystallization continues until the pan is full and the desired sucrose concentration is achieved. The resulting dense mixture of syrup and sugar crystals, known as masoquite, is then discharged into large containers called crystallizers. Within the crystallizers, the masoquite is slowly stirred and cooled to facilitate further crystallization. Subsequently, the syrup undergoes separation from the sugar crystals through a high-speed centrifugal machine, spinning at 1200 RPM. The molasses, or mother liquor, is separated from the sugar crystals, which remain inside the perforated centrifugal basket. To remove most of the syrup coating and produce raw sugar of high purity, the crystals are sprayed with a fine jet of water. The raw sugar from the centrifuges typically contains 97 to 99% damp sugar crystals. To reduce the moisture content, the damp sugar crystals are dried by tumbling them through heated air in a granulator. This process reduces the humidity level of the sugar to approximately 0.02%, meeting the standard for table sugar. The dried sugar crystals are then transferred into bags that can hold up to 1,000 kilograms. A hoist is employed to carry the bags to a packing facility with the capacity to transport 3 bags at a time, totaling 3,000 kilograms. At the packing facility, each bag is carefully opened and the sugar is poured into a chute that leads to the factory's main floor. An automated packaging machine fills a series of 2-kilogram plastic bags. Maintaining mill sanitization is of utmost importance in quality control, as scientific studies have shown that even minute amounts of sugarcane fiber residue can contaminate the entire flow of warm juice. To address this concern, modern mills incorporate self-cleaning troughs designed with the appropriate slope to prevent residue accumulation and ensure its smooth flow with the juice stream. Stringent measures are also implemented to control insects and pests within the mill premises. Efficient transportation methods are crucial for the prompt delivery of sugar cane to the mills, as cane spoils rapidly. Automation has been introduced to streamline transportation processes and minimize delays, ensuring that the cane reaches the mills promptly. To preserve the high quality of brown and yellow refined sugars, which typically contain 2 to 5% moisture, careful storage in a cool and relatively humid environment is essential to prevent hardening. If you have a sweet tooth and found this video interesting, watch our video on how chocolate is made.